Going into the next video, this video is going to be specifically only on atomic radius. And just because I think it's the most important one, I want to make that extremely clear. And I'm going to put a little star guy right here as a way for you to remember that this is the most important one. Also, for the sake of this video, I'm going to delete everything dealing with the other two so we can specifically talk only about atomic radius. Now, the big things with atomic radius is, honestly, why is it really big over here and really small over here? So to do that, we need to talk about up and down and left and right. And again, these work for every column, every row. So I'm talking about specifically using the first column as an example. It works through the second column all the way to the 18th. And that idea is going down, there are more layers and more orbitals. So for example, what you'll see, and this will not be perfect by any means, every single time you go down the periodic table, you are going to get bigger and bigger because the orbitals are going to start to overlap each other. Layers. Kind of think of it like an onion, right? From Shrek, right? Ogres have layers, onions have layers. As you gain more and more layers, you're going to be getting bigger and bigger and bigger. And I think I'll stop here on this last one. But this will go all the way through 7. And as you can see, the one with 4 is bigger than the one with 1. That's why francium is huge, because it's at the bottom and has 7. Think of it like putting coats on. The more coats you put on, the bigger you get. It's the same thing. Again, this works here, 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 here. It works the whole way. But there is a different trend when going from left to right. And to do that, I'm specifically going to be talking about this one, just because it's a little bit easier to see. And that is this idea down here. As you can see, here I have 1 proton, 1 electron. 3 protons, 3 electrons. 7 protons, 1 electron. And as you can see, as I increase the number of protons, the electron is closer to the proton. Think of it like tug of war, right? If you have more on your side, it's going to be pulling it closer. And that's because as you gain protons, you're able to pull in more. 7 positives pulling on 1 negative is going to do a better job than 1. Again, think of it like tug of war. If you have a team of 5 on 5, it's going to be pretty equal. 5 protons, 5 electrons. If you get a team of 9 protons with 5 electrons, that 9 is going to start pulling the electrons in a little bit, thus shrinking the radius. Again, this would be the atomic radius. It's not that big. This one's bigger. This one is the biggest. How does that work here? Again, going left to right on the periodic table, right? 3 to 10, more protons over here. 11 to 18, more protons over here. 19 to 36, 37 to 54, and so on. More protons over here. So what happens is they start to shrink because those protons are pulling things in. And again, you can see that it's the same drawing with all the rings. And again, I'm going to run out of space to do this very quickly. You guys get the picture. As you go in, I'll do one more. We get smaller and smaller. The reason I did this bottom one is because I think it's visually easier to see with more rings than just me making this really small. That's why fluorine's the smallest. Not only does it have only 2 shells because it's in the second row, its 9 pull in a heck of a lot better than 3, 4, 5, 6, 7, 8.